good morning, everybody. We're going to do a little new topic called identity and inverse matrices. All right. The first thing we need to know the difference of is what in the world is an inverse versus an identity. So if we have any matrix and we multiply that matrix by its inverse, what do we get? If this is a 2 by 2, these are both 2 by 2s, what's the identity matrix, Austin?
1, 0, 0,
1, 0, 0, 1. So if you have two matrices multiplied together and they're inverses of each other, then you're going to get the identity matrix. Well, what if we had a 3 by 3 and we had one matrix and we multiplied it to the inverse of the other matrix? Xyla, what's the identity matrix going to be for a 3 by 3? It's 1, 0, 0, 0, 1, 0, 0, 0, 1. All right, so you see the ones kind of going diagonal. Okay? So, once again, this becomes the identity matrix. Now, why are identity matrices important? Because if you take any matrix, like 1, 2, 3, 4, 5, 6, that's not a 6, 7, 8, 9, and you multiply it by an identity matrix, Baylin, what am I going to get when I multiply this matrix times an identity matrix? What am I going to get? Same numbers, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. So once again, this is the identity matrix of a 3 by 3. All right, so anytime you multiply a matrix times an identity matrix, you get itself. All right, so when we go back to problem number 4, problem number 4 asks us to determine whether or not these matrices are inverse. So I'm going to zoom in on problem 4 because it deals with fractions. Okay, and what we're going to do is we're going to multiply this row and this row times this column and this column. All right, we're going to be multiplying matrix P times matrix Q. All right, if we get matrix P times matrix Q, and we get the product of 1, 0, 0, 1, what does that tell us about P and Q? Those are inverses. So Kyle, help me out. Where do we start with? What number do we start with when we're multiplying? All right, so we have 6. So 6 times, you said 3/14. All right, plus -2 times 1/7. And it's this 1/7, not this 1/7. This row has to be multiplied to this column. First times first plus second times second. All right, what's the next one, Cal? Keep going. 3/7. Good. That's right. All right. So at this point, once we have this row set up just like this, once we have it set up, what makes it? What's the easy process we can do next?
You just drop them down.
Drop what down? I'm confused.
The things that we see.
All right. So we are able to drop these numbers that were in our columns straight down without really having to think a whole lot. We just follow a pattern. Once we've established a pattern, we can follow it. Okay. Now instead of a 6 and a -2, a 6 and a -2, what am I going to replace those numbers with, Austin?
2, 3, 4, -2, 3.
-2 and a 3, -2 and a 3, and I got to make sure I put a plus and a plus. Okay. Now I realize that this sum is not always the easiest thing to do by hand. Okay. So these right here, you can use the graphing calculator, and we'll show you how to use the graphing calculator, and we'll also show you how to do it by hand. So You're not so dependent on it, okay? All right, the first thing we're going to do is we're going to do it by hand, okay? This right here is 6 times 3, which gets me to an 18 over 14. Now, that reduces, if you divide both sides by 2, that reduces to 9 over 7, okay? Then here, we're going to say plus a negative 2 over 7. And when you get 9 over 7 minus 2 over 7, that's 7 over 7, which is a 1. So that first one is 1. Over here in red, we have 6 times the 7th, which is 6 over 7. All right, take the 6 and multiply to the 1. All right, so plus, we have negative 2 times 3 sevenths, which is negative 6 sevenths. And when you add those together, you get nothing. We're on the right track. This is looking good. All right, here, what's the product of a negative 2 and 3 14ths? It's a what? Negative 6 14ths. But that reduces to what? That becomes a negative 3 over. If you take half of this and half of this. This was my daughter. My daughter has a test today, so she has to like simplify fractions and find things. No, she's in 6th grade, but she has to simplify fractions and do least common multiples and greatest common factors and stuff like that. So we studied last night. So hopefully she will know how to do this, because she's gonna have to know how to do this even now, even if we're doing stuff like this. So we add these together, we get 0. And over here we have negative 2 over 7. Plus we have 9 over 7, because 3 times 3 is 9. Then we add these together and we get 7 over 7, which equals a 1. So what does that tell us about matrix P and matrix Q? These are indeed what? Inverses. So we can say yes, they are inverses. But let's say you have a graphing calculator and you're like, I don't want to be able to do this by hand right now because I'm feeling a little lazy. All right? Well, we'll do the blue one in the graphing calculator to show you how to type things in, press enter, and show you that it does indeed get a, well, not that you're lazy, but just in case you are. All right, so we're going to do this one in blue here. We're going to go to our calculator. We're going to type in a 6 times, what was it again? 3 14, so 3 divided by 14, close parentheses, plus, what's the next one? Negative 2 times 1 divided by 7. So that's exactly how you can type in the calculator. And you get a 1. All right, now, you could also do 6, open parentheses, alpha y equals, enter, and do the 3 over the 14 like this. And then you could do alpha y equals, enter. If this, for some reason, you like the look of this better, it takes a little bit more steps to do, you still get the same answer. Okay? But if you want to type it in the calculator that way, you'll still get the same answer. All right, now we're done with that. We're going to move on to how to find an inverse. All right, we're going to find the inverse of number 8 right here. Now, there's a formula for finding an inverse. We're going to call this matrix A. All right? If I wanted to find the inverse of matrix A, we have a certain formula. It's 1 over A times D minus B times C. This is where it gets a little tricky. All right? This is where you're probably going to write this down in your journal. All right, if I label this lowercase a, this lowercase b, this lowercase c, this lowercase d, how do I rearrange the numbers in this formula right here? We start with a d, and the a, those are going to switch places. And here this becomes a negative b, and this becomes a negative c. So this is the formula that you have to use. You might want to put this in your journal. It's not something that you will probably remember or text to each other. Hey, remember that formula? You're not going to do that. All right. So at this point, the first thing I want to figure out is what the heck AD minus BC is. So let's do that first. Okay. So we're going to do A times D minus B times C. So what's the product of A and B? What you got, Nick? Product of A and D.
What?
Product of A times D. A and D.
2 times 3 is 6.
Bam. Okay, minus. We gotta be careful here because this says the product of B times C, which is a -5. What's gonna happen to these negative signs? In a positive way, they're going to go together. In a positive way, not just go together. All right. So right here we have an 11. Now, Bree, on one of the problems, you had an issue because right here, when you did AB minus BC, you got the number what? You got the number 0. Okay. So this right here, if you get a 0, that means there's no inverse. That inverse does not exist for that 2 by 2 matrix. So this right here, everybody, I want you to understand. AD minus BC right here can never, ever, ever equal 0. If it does, stop working. We can't go any further. Okay? Now, we can go further on this one, Michael, so help me set this up. What am I going to do? I'm going to start with a 1. 1 over n 11. All right, you're going to start with 1 over 11. Now, I want you to look at these numbers and look at how we need to rearrange. So how do I need to rearrange it right here? 3. So 3 goes here, so what goes down here? 2. All right, 3, 2. Now, my B is 5, but I want a negative B, so what do I want? -5. Good. And my C is -1, but I want a negative C, so I need a positive one. There we go. So, understand you got to set things up. Don't just do things in your head. Set it up, and then we can solve it. Now, what does this number right here, this 1 over 11 represent? That's simply a scalar, right? So you got to distribute it to each of these numbers. All right, so Xylem, why don't you distribute it? Let's get our final answer. Take that 1 over 11 and multiply it to all of those numbers. What do we left? There we go. So, all right, 3 11s. Good. -5 11s. 1 11. There we go. All right. Now, if we took this right here, if we took this matrix and we multiplied it to this matrix, what would we get if we did? We're not going to do it. If we did that, what would this matrix times this matrix equal? If we took A and we multiplied it by the inverse of A, which we're saying this is what the inverse is equal to.
0.
It wouldn't equal 0.
1.
Say it, Mike. 1, 0, 0, 1. It would equal the identity matrix, okay? So this times this would end up equaling this. So this is your final answer for number 8. And that's basically what we're doing on this assignment, is learning how to find inverses and also checking if matrices are inverses of each